All right, welcome. This is the IM2 Week 1 Distance Learning Solution Packet. Here I'm going to be covering page 2, which looks something like this. All right, so what we're going to do here is we are going to simply simplify a radical. But what does that mean to simplify a radical? All right, we have to understand what this means first of all. Okay, simplifying a radical. Simplify means to get it in a very, let's say, in a very compact situation. So, let me show you. Right, the example I want to use here is square root of 20. Right, square root of 20 is not simplify. Why? Okay, this is made up of factors. So this is made up of factors. And again, factors are numbers that you can multiply. So let me just write it out. Here's your list of factors. Okay. We had 1 times 20, 2 times 10, 3, no, 4 times 5. Okay. I know this is all my factors because these two numbers are close together. So far these will make up this. Okay. So we are trying to simplify it by reducing it into a smaller compact term. So let's take a look. Let's say I can do it like this. I can break this up into 1 times 20. Does that help me? No, because the square root of 1 times the square root of 20 is just 1 times 20. Okay? This doesn't do anything. This gets you the same answer. So it doesn't do anything here. What about, let's try 2 and 10. Okay, 20 becomes 2 times 10. Can we do the square root of 2 times the square root of 10? This is not good. This is not good because this is not a perfect square. 2 is not a perfect square. 10, is that a perfect square? This is also not a perfect square. So far this is really bad. Okay? All right. So let me show you how to do it now. Okay? I show you how not to do it. Now let me show you how to do it. All right? So here I have my list of perfect square roots. Okay? Let me give you my list of perfect square roots. And we are going to break down or simplify this radical. Radical 20. Okay? The two factors that I'm going to decide to use is 4 times 5. Okay, this is just breaking it up into its factors. Okay, notice one factor is perfect. All right, here you should remember this from 6th, 7th grade. Right, your list of perfect squares. Now here you can split it. This is a property of radicals. You can split it like this. Okay. All right. I'm not going to go into an explanation on why this is true. Okay. This has to do with something with the law of exponents. Okay. All right. So I split it. This is good because this is perfect. It's on this list. Do you see that? The square root of 4 becomes 2. So this becomes what number? Becomes the number 2. Anything happens to the square root 5? No. So it just remains square root 5. So notice from here to here, so this is the original number. From here, we simplify. Why? How do we know it's simplified? Because the number in the radical can no longer be broken down. Okay? This is when it simplify. Okay? We know that the number in the radical can no longer be broken down. And again, how do we break it down? We break it down into its factors using the perfect square roots. Okay? So that's how we do it. All right, have this memorized. Okay, so let's do this one. Square root of 40. All right, so start out by listing out its factors. So we know its factors could be 1 and 40, but that's useless. 2 and 20 looks pretty good. What about 3? Nope. What about 4 and 10? Ooh, 4 is a. Do we have 4? Yeah, 4 is a pretty good one. What about 5 and 8? Is 5 one? No. Is 8 one? No. Nope, they're already close together. Okay, so we know this is useless. 2 and 20, are those perfects? No. Well, no. 5 and 8, that's not perfect. Oh, seems like 4 and 10 are. Okay, so we're going to break this up. Square root of 40 becomes 4 times 10. Okay, watch how when I split this up. This becomes square root of 4 times square root of 10. Okay, do you see how here it looks like this? Perfect, right? What is the square root of 4? Becomes 2. What is the square root of 10? Nope, you leave it there. Okay, what's the factors of 10? 1 and 10, 2 and 5. Anything here perfect? Nope. Nope. That's why you know that this is simplify. Okay? Good. There you go. You have to make sure you use this, okay? All right. So, let's go on to the next one. All right? So, this is number 2. Again, here's our list of perfect squares. This is something that you're going to try. You are going to try this one. Try this one first. Okay. Again, let me give you the list of factors to help you out. Okay. 1 times 50 is one of them. 2 times 25. 3 times 4. Does 4 work? No. 5. Yeah, 5 and 10 works. Nope, that's it. These are all the list of factors. All right. So go ahead. Now you can try this problem. Okay. Again, make sure you break this down. So let me show you. This should be broken down into something like this. Okay. Something multiplies by something else. Then it be broken down to this times this. And one of these has to be perfect. Okay. All right. Then you get your answer. Okay. There you go. Try number 2. All right. What about number 3? Oh, number 3 is a little bit harder because this time it's a cube root. All right. So a cube root uses one of these. Okay. It's the same thing, but it's a cube root. So you're gonna use your before these were perfect squares. Okay, that we weren't using because do you see how the radical here is a square root? Here this is a cube. So you are going to use what? Your list of, these are your lists of perfect cubes. All right. So let's list out its factors. Here are its factors. We are going to list out 1 times 16, 2 times 8, 3 times no, 4 times 4. Okay. All right. So 1 and 16, that doesn't work. What about 4? 4 isn't here. 4 is a perfect square, but not a perfect cube. 8, so let's break this down. So 16 becomes 2 times 8, right? And again, this is cube root, all right? So we have your cube root of 2 times your cube root of 8, okay? This, nothing happens to this. What about this? We know that that is your 3 radical 8 is equal to 2. So this number becomes 2, right? Do you see how it just comes down? Now you can rewrite this. It looks like 2 times like that, okay? That doesn't look that pretty. Here, let me make it a little bit pretty. Here, radical 3 here, and that's a 2. There you go. That's how that would look like. Again, this is a cubed, so that's why you're using lists of perfect cubes, okay? And I think I have 4 down here. Yep, this is a square, so Ooh, that's very interesting. Let me get my list of perfect squares here. All right. Okay. 72. This is very interesting. So let's just again start by doing our list of factors. Factors, and we have 1 times 72. Um, we have 2 and 36. See how useless. Um, 3, does 3 go to 72? Yeah. 324. I'm just using a calculator for this. Divided by, oh, I also have 4 and 18. Anything else? 72 divided by 5. Nope. 72 divided by 6. I have 6 and 12. 7, no, 7 does not do that. What about 8? Ooh, 8 and 9. All right, so let's look at all the good stuff. 1 and 72, no. 2 and 26, no. 3 and 24, 3 is not one of them. 4 and 18, yeah, 4 is one of them. 6 and 12, no. Ooh, 8 and 9. These two are perfect, okay? And I'm going to show you both ways of doing it, okay? So I'm going to show you the first way. So this is using 4 times 18, okay? So let me show you. Right, you're going to see how it's going to be the same, okay? So the square root of 72 is going to be broken down to 4 times 18, right? So what is the square root of 4 times the square root of 18? Okay, we know that the square root of 4 is broken down to 2. Square root of 18, again, I have to break it down into its factors, which is going to be 2 and 9. Okay, so this is going to be multiply. 18 just be broken down into 2 times 9. Okay, split this apart again so I can reduce. Okay, because I know square root of 9 is 3. So it's 2 times square root of 2. Do you see how everything comes straight down? Square root of 9 becomes 3. So you can now multiply. 2 times 3 is 6. Square root 2. That's the answer. Okay? I'm going to move this a little bit to the right. Okay. Now, watch me use the other way. Do you see how this is a little bit longer? Let me using 8 times 9. Watch how beautiful this is. Okay. The square root of 72 can be broken down into 8 times 9. All right. Okay. This, okay, I'm going to break down this a little bit more. 8 can also become this, the 8. I'm just going to do 4 times 2. Right. So I'm going to break this down a little bit more. So this is 4 times 2 times 9, right? Because again, this is where the 8 is. Now I'm just going to split this into 3 pieces. The 4 times uh, the 2 times the square root of 9, right? You should already see this. It's right here. So square root of 4 becomes 2. Square root of 2 becomes nothing. Square root of 9 becomes 3. Okay, do you see how this and this is the same step? So this just becomes 6 square root of 2. Okay, it doesn't matter which factor you're using. The larger the factor, the less steps. But if you want to use the smaller factors, it doesn't matter. You're just going to have more steps. Okay, good. Let's do this one. And I think this is 4, so it still doesn't matter. You're still going to use your perfect square roots here. All right. So let's. There's multiple. Is this perfect? Let's see if 81 is actually a perfect quad root. Let's see, 4 times 4 times 4 times 4. No, 3 times 3 times 3 times 3. Yeah, this is actually perfect. I was just testing out the values. Here, this is actually perfect. This is a perfect quad root. Okay? Because check it out. 1 times 1 times 1 times 1 is 1. So that means the cube root of 1 is equal, the quad root of 1 is 1, right? 2 times 2 times 2 times 2 is equal to 16, right? That means the quad root of 16 is equal to 2. 3 times 3 times 3 times 3 is 81. That means the cube root of 81 is 3. Okay? So here, we can just simplify this into just 3. Okay? That's it. You can do this using the square root, but it's just uh, mm, it's gonna get more complicated using properties of radicals. Okay, so again, here you go. This is simply using your not your perfect square root. This is gonna be using your perfect quad root. Okay, good. And oh, square root of 32. That is a very easy one to do. So this one you are going to try yourself. I'm not gonna give you the answer. I'm gonna give you some steps. So let me help you by giving you the factors. Right? 1 times 32, 2 times 16, 4 times 8. Anything else? Okay. Remember, 132 doesn't work, and I think the rest should go. I think there's one more. Um, 6. Does 32 go into anything? Hold on. 1 times 32. 32 times. No. 32 divided by 16. Oh, yeah. 2 and 16. Yeah. So look at these two numbers. See which one uses a perfect square root. Okay? So here, let me give you the first step. Okay? You can do it either two ways. Okay? Let me just move this over. Let me move this over. Okay? So for this one, you can either go here. Square root 32 can be, you can try 2 times 16. This is step 1. Or you could do option 2. Square root 32 can be 4 times 8. Okay? Your perfect square is this one. Your perfect square here is 16. This is your perfect square is right there. Your perfect square here is 4. All right? Okay? Here you could take on and do the rest. All right? But that should already help you on the way there. Okay? 7. Ooh, is this perfect? Pent cubed? This is a pentacube, I think. So let's see. Does this even work? 4 times 4 times 4 times. No. 3 times 3 times 3 times 3 times 3. No. Ooh, 2 times 2 times 2 times 2 times 2. No. This is very interesting. This is very interesting. You can't use your so this is not this is not perfect by all means. Okay. And it's a 5 too. That is brutal. Okay. So let me think how to do this. Well, let me use my list of perfect squares first of all. No. I don't like the perfect squares. Eh, you know what? There might be an easier way of doing this, but I'm going to use perfect squares, okay? So, what are my factors of 16? I have 6. Ooh, I have 16 and 10, right? Right? So, I have 16 and 10. So, I have 1 and 160. I have 2 and 80. I have 4 and 40. I have. Can 6 goes into this? 4, 6, 16. Can 16? Yeah. I know the 16 times 10 can go into it. 12, 12, 15, 15. Ooh, what about? No, not 25. 16. No. So I'm going to end up using 16 and 100s, okay? This I don't even think this is going to work out pretty, right? So I broke it up. No, this is not perfect. Okay, this is not good. This is not good. This is a bad approach because, yeah, it's a bad approach. So you know what I'm gonna do? Okay, let's try. Let's make a list. Let's make a list. We're gonna make a list. Okay, let's make a list. This is gonna be your list of perfect um, pentacube. Okay. I don't even think this is a like the real name for it, but that's what I'm just gonna call it. List of perfect uh, pentacubes. All right, so let's go over it. So we know that 1 times 1 times 1 times 1 times 1 is equal to 1. So the pentacube of 1 is just 1. Okay, let's try 2. 2 times 2 times 2 times 2 times 2 is equal to 1. 2 times 2 times 2 times 2 times 2 is 32. So this is 32. So I know that the pentacube of 32 is 2. Let's do 3. Okay? I know 3 times 3 times 3 times 3 times 3 is equal to 243. So I know that the pentacube of 243 is uh 3. Can I break this down using 32? Yeah, you can. You actually can. So this actually works. So this actually works right here. This actually works. So I break this down into its factors, okay? Square pen, the pentacube of 160 can be broken down into what? 32 times 5. Okay, so break this down. The pentacube of 32, right? This is the first part, times the pentacube of 5. We know this is a what? This is one of the perfect. So this breaks down into the number 2. Nothing happens here. So pentacube of 5. There you go. That's your answer. This is very hard to do if you don't recognize the pentacubes. Again, like you can't actually find these on the internet. The internet only gives you the perfect square roots and the perfect cube roots. They don't give you these, okay? Right? And I don't even think this is the correct name anyways. Pentacubed? No. Penta I think it's pentaroot. Pentaroot, right? I think it's called a pentaroot. Okay. I don't know the exact math term. Pentaroot. Okay. Let's do 8. Oh. Ooh, I love 45. 45 is a very pretty one. Um again, this one's going to be an easy one to do. Okay, this is easy. Let me see if I'm gonna do this one. I'm gonna do the next one. No, I'm gonna do. I'm gonna give you 3 radical 54. Okay. Um, but I'm gonna show you this one, right? This. Okay. What? Let's go over its factors. Okay. Let's go over its factors. All right. I have 1 times 45, which is useless. Nope. 2, 3, 4. 4 times no 5. 5 times 5 times 9? Yeah, 5 times 9, right? Okay, good. And I think there's nothing else. So this is useless, so I'm just going to end up using that one. So this is very easy. Square root of 45 can be broken down into 5 times 9. Split this apart. Radical 5 times radical 9. This, nothing happens to it, but we know this is perfect based on our list right here. So this becomes what number? 3. So it's radical 5 times 3, which in simple English can just be 3 radical 5. Okay? All right. And last one, the cube root of 54. All right, let me just give you the cube root list. All right. And let me just grab that for you. Boom. Here you go. That's your cube root list. All right. Let me just give you the list of factors. You're gonna try this yourself. Yourself. Let me help you along. Here are its factors. 1 times 54. Do you want to use 1? No. Do you want to use 4? Can 4 do that? 50. Yeah. Oh no. No. 4 wouldn't. 4 isn't pretty. No. Sorry. 8. 54 divided by 8. No. What about 54 divided by 27? Ooh, yeah. So this is 22 times 27. This is what you're going to end up using. So let me help you along with the first step, okay? So this, the cube root of 54, why can't I ever make it straight? Can be broken down into the cube root of uh, 2 times 27. Okay? So split this apart. Cube root of 2 times the cube root of 27. Okay? This is where I'm going to stop. You can finish. Okay? Using what you know here. All right? So there you go. I think that's it. Okay? Yeah. Yep. You are going to try 2, 6, and 9 by yourself. Uh, and the rest, I showed you how to do it. So watch the other videos if you need help, okay? But there you go. Those are all your solutions.